Hello everyone, my name is Billy and welcome to this video. Today we're going to expand a little more on arithmetic sequences. Let's start with a recap on what we talked about in the video just before this one. We talked about a sequence of numbers being numbers that are written down one after the other, separated by a comma. And sometimes you will see this symbol, an ellipsis, which means there are more to come, but I just haven't written them down. If I just present it to you this way with an ellipsis on the end, this is an infinite sequence. If I decide to put one more or two more at the end and put a full stop at the end of it, this means that this is a finite sequence because it has a definite end number. We also talked about naming each of these terms t. So this first term is t1, and we talked about this subscript here being n. So in this case, for the first term, n is equal to 1. In the second term, n is equal to 2. And if I went on and let's say I did not know how many terms there were, I would just call this last one tn. Now, if I had another term inside here, I would call that one tn minus 1. So just think of this, or think of these subscripts as ways to name the terms. We also talked about the differences between successive terms. And this is what we mean, the difference between these two terms and these two terms. And the way to find the differences is simply to take one term minus the one before it. So this distance here is going to be t2 minus t1. The next distance, let's just label this one as t3, is going to be t3 minus t2, and so on. And if these differences happen to be the same value, let's say d, then d is called a common difference. And in fact, if the difference between successive numbers in a sequence is the same, that sequence is referred to as an arithmetic sequence. Arithmetic sequence. The next thing we looked at was how to find a term. So let me just draw this out in squares again. Let's call this t1, t2, t3, t4. Actually, let's just keep going up to, I'm going to call this one tn, comma, and then this one tn plus 1, and I'm going to end the sequence there. Actually, I'm also going to squeeze another term in here, and I'll call this one tn minus 1. We'll put a comma in here and the ellipsis in here. So let's just stop and take a look at what I've done here. I've written out a finite sequence. This one in pink is tn. So the one after it on this side is tn plus 1. And the one before it on this side is tn minus 1. So for example, if this was the 50th term, then tn plus 1 means this is the 51st term. And on the other side, this is the 49th term. If you're ever confused by the n and the n minus 1, n plus 1, do what I've done, put some numbers in, and suddenly it becomes very clear. In the previous video, we talked about how to find any term tn. And I showed you this formula, tn, so the one I've circled in pink. To find that, I take the one before it, so tn minus 1, and I add on the common difference. Now there is another way to write it, and that is to focus on the term ahead of you. So it's this one. So if I want to find the tn plus 1th term, I take the one before it, which is tn, and I add on the common difference. Now, both of these functions are actually telling you the same thing, and that is when you want a term, you take the one before it and you add on the common difference. Depending on what your teacher presents to you or what textbook you're using, you could use either one of these, and they are telling you the same thing, so they'll give you the same answer. These functions are called recursive functions. A recursive function is one that just keeps repeating itself by using itself. Let's take a look at some problems now. I'm going to write down, let me just write problem solving here so that you know where we're at. Let's take this first sequence, -4, -2, 0, 2, and 4. And for this one, I want you to do a couple of things. First of all, I want you to tell me if this is an arithmetic sequence or not. And the second thing is to find the recursive function. So the way to find out if it's an arithmetic sequence is to calculate D. Let's just label these terms before we keep going. T1, T2, T3, T4, and T5. And remember how to determine if it is an arithmetic sequence. The values of D must be the same. So let's start to calculate D between T2 and T1. So D is going to equal T2 minus T1, which is -2 minus -4. This is -2 plus 4, and that is equal to 2. So that's my first answer. This D in here is 2. Right, let's do the second one. T3 minus T2 is equal to 0 minus -2, which is 0 plus 2, and my answer is 2. So D here is 2. All right, so it's starting to look good. We've got 2 more to do. I'll do 1 more and you do the last one. Okay, so T4 minus T3 is 2 minus 0, which is 2. Looking good. And the last one I'm going to do in my head. So it's going to be 4 minus 2, which is 2. So the values of D are the same. So yes, this is an arithmetic sequence. Now the next thing I wanted you to do was to find the recursive function. So let me just erase this to give myself some space. So I've now calculated D, and D is equal to 2. Now I'm just going to show you the 2 functions here, and I will use both of them so that you can have an idea of how they would look like. So the first one is the function Tn is equal to Tn minus 1 plus D. So this becomes Tn is equal to Tn minus 1 plus 2. So this is my first form of the recursive function. Let's look at the second one. I'll just show you or remind you what it is again. Okay, it's this one here now. So that Tn plus 1 is equal to Tn plus D, or Tn plus 1 is equal to Tn plus 2. That's the second one. This first one, you would say the term you are looking at is the one before it plus 2. This one you're saying the term, or rather the next term, is the one you're looking at plus 2. All right, so 2 ways of writing a recursive function. Before we go, I want to show you one last thing, and that is when you have a negative value of D. Let's take a look at this sequence here. 80, 62, 44, and the last term is 26. Put a full stop at the end of it. Now you can see the numbers are getting smaller. All right, so let's calculate D. I'm going to label this T1, T2, T3, T4. So D is equal to let's take these two terms. Remember, you always take the term and then you subtract the one before it. So this one is 62 minus 80, and my answer is negative 18. Right, let's try the next one. This one here, t3 minus t2, that is 44 minus 62, which is also negative 18. And let's just try the last one. Let me try yellow. That will be between this number here and this number. So d is equal to t4 minus t3, 26 minus 44, which is also equal to negative 18. So now we can write the function out. Let's write it out two ways. The first way to write it is tn, so that the term you're looking at is the term just before it plus the common difference. Let's rewrite that. Tn is equal to tn minus 1 plus negative 18. And if we tidy this up, tn is equal to tn minus 1 minus 18. Now let's write it the second way. The term ahead of you is the term you are looking at plus the common difference. So tn plus 1 is equal to tn plus negative 18. Tn plus 1 is equal to tn minus 18. So this is the way to write out the recursive form of this sequence in both ways. I hope this video has been helpful for you. Thank you for stopping by and watching. Next time we will look at how to develop the general form or the general term of an arithmetic sequence. See you then. Bye.